So, I will demonstrate X-ray diffraction experiment. So, X-ray diffraction method. So, diffraction can occur whenever the Bragg condition, Bragg law 2d sin theta equal to lambda is satisfied. So, this is the main equation or law for X-ray diffraction 2d sin theta equal to lambda. So, only we are considering first order n equal to 1. So, in crystal there are many planes in different angles. If you take a crystal, so it will have many planes in the crystal. So, that means d is the planar distance. So, d is variable in a crystal, but these d are at different angles. So, in crystal d of different value is available. In X-ray, white X-ray, lambda is variable, and also theta here can be varied. So, here you see 3 parameter, one is d, another is theta and lambda. So, in white X-ray, lambda is variable. So, you can choose any lambda, you have option. D in crystal there are many value of d, which that is why we tell the DHKL for different planes. So, d are different. So, in crystal also there are many d available. So, you can choose a particular d. So, d also variable, and theta is the basically angle of the incident X-ray with the surface of the sample. So, that we can have provision to vary the angle theta. Okay. So, which one will be variable and which one will be fixed to satisfy this Bragg condition? Depending on that, there are 3 methods. So, one is called Lau method, Lau, L-A-U-E, Lau method. So, in Lau method, lambda is variable, that means white X-ray is taken and that white X-ray will fall on the sample, and this angle theta is fixed. That means sample is fixed, its planes also are fixed. So, incident X-ray are falling on it. So, angle with the sample planes are fixed, but theta lambda is variable, all sorts of lambda white X-ray is used. So, then lambda is variable. So, now theta is also variable, sorry, theta is fixed. So, in this crystal there are many, as I told, there are many planes are available. So, for different plane, different lambda will be chosen, different lambda by nature will be chosen, so that this equation will be satisfied for different d and different lambda when theta is fixed. So, if experiment is done in this geometry, then it is called Lau method. And another method is called rotating crystal method. In rotating crystal method, lambda is fixed, means white X-ray is not used. This using the absorption filter, one wavelength is chosen, generally K alpha wavelength is chosen. So, lambda is fixed. So, X-ray of particular lambda is falling on the sample. Now, in sample, this rotating crystal method means these crystals are rotated in step by step. So, in that sense that theta is not continuously variable. So, theta can be changed in different steps. So, theta is basically variable, lambda is fixed. So, lambda is fixed. So, for different plane there will be different theta. So, then again you will get Bragg diffraction and you will get Bragg peaks. Okay. So, next method is powder method. Powder method. So, if you have a crystal, single crystal, so now if you break it, make it powder. So, that crystal now it is in form of powder, means small particles will be there. So, that particles is basically crystalline particles. Now, in each crystal there are all sorts of planes are available. Now, these crystals itself is oriented in randomly. What does it mean? So, in one particle, so if 1 1 1 plane is in this direction, this is the 1 1 1 plane. So, direction is perpendicular to that. So, now for this particle, this is the 1 1 plane. For next another particle is randomly oriented. So, 1 1 1 plane is in this direction. So, other is directed. So, this 1 1 1 plane, 1 1 1 plane, as if this it is a continuously variable. So, incident X-ray when it will fall on the powder sample, this 1 1 plane, 1 1 1 plane. So, this X-ray will see 1 1 1 plane in all direction. So, that is from different particles, but so in this case you can see this by nature in powder sample, this each plane, not only 1 1 1 plane, each plane 1 0 0, 1 1 0, 1 1 1, all planes. So, as a whole HKL plane or continuously variable, this their angle with this incident X-ray will have the continuous theta variation. Okay. So, it is the completely variable. So, this is telling this powder method lambda is fixed, theta is completely variable. Okay. So, now this lambda wavelength X-ray will see all planes with all possible angles. So, only when for, so you can expect that for, so theta is variable, lambda is fixed. So, d for different d, say at different theta, this equation will be satisfied. Okay. So, in rotating crystal method, to vary the angle, so we just vary the change the angle of the sample. Okay. So, this method is used generally in case of bulk material, in case of thin film. Okay. So, there we need to vary the angle using some mechanism, using some goniometer. So, in powder method, so we do not need to vary the angle, change the angle of the sample, because already in powder form this all planes have all sorts of angles variation in the sample. So, by nature variation of angles are there. So, this method is powder method. In our laboratory I will demonstrate this powder method. Okay. So, this is very popular method. Other two method I will not discuss. Comparatively this powder method is widely used and very useful, and that is what I will discuss. So, as I mentioned, this is in powder method we will, so this some bulk material, I have to break this bulk material, make powder. So, means small particles. So, these small particles, they have they are crystallite, they have all sorts of planes, and these planes are in different particles or in different direction. So, thousands and thousands particles are there. So, you can expect that each plane will have these all angle, they are oriented in all angles. So, so now this X-ray will fall on these powder sample, where this Bragg condition will be satisfied and get this kind of XRD pattern. We tell XRD pattern, X-ray diffraction pattern. Okay. So, as I explained that any plane say 1 on 1 is randomly oriented in powder sample. By nature D11 or any DH scale for a set of parallel planes 1 on 1 will make continuous angle theta. So, for a fixed lambda at a particular angle, Bragg peak will appear for different DH scale. Okay. So, what does it mean? Here we will get Bragg peak. So, here I have shown many Bragg peaks. So, each Bragg peak is basically from a particular plane, set of plane. So, this peak indicates a particular planes, and as I mentioned that from this experiment we basically find out this angle. Here I have written 2 theta, one can write theta also, but 2 theta generally in powder method we prefer 2 theta, because I will tell in next transparency why we tell 2 theta. So, here you can see this, you have a sample here. So, just I have drawn a plane in that sample. So, X-ray is falling on it. So, this angle with this plane is theta. So, so then it will be reflected or diffracted at angle theta. So, this 2 theta angle is basically with respect to the incident X-ray. With respect to the incident X-ray, so the X-ray will be diffracted at different angle. Okay. Now, as I told this, we do not need to vary the angle of the sample, it is fixed. Now, only to catch this diffracted peak, diffracted intensity of X-ray, we use detector, and that detector we just scan over a 0 to 90 degree or minus 90 to plus 90 degree, we just scan. Okay. So, generally we scan 0 to 90 degree. So, if you scan, so this detector will tell you that at which angle the diffracted beams are coming. So, so that is why we plot here variable is 2 theta. From 2 theta one can find theta dividing by 2. So, when it scan, so it just noted down this variation of intensity of X-rays at different angle. So, we get peak when this Bragg condition is satisfied, and from these peaks generally we get the information about the crystal. So, what are the information we get that I have discussed. So, if I will discuss more when we will analyze the data. So, let me, so now for your experiment what you need? We need X-ray source. Now, this X-ray source in powder method we need X-ray of particular wavelength. So, we will use filter. So, from after filtering, so we will get K alpha, that K alpha X-ray will fall on the sample, powder sample. Now, it will be diffracted in different angles depending on the different planes. So, now we should have a detector, and that detector should have option to scan from 0 to 90 degree. So, now I will show you our diffractometer, powder X-ray, this is a powder diffractometer. So, here you can see this is the machine. We tell this X-ray machine, and it is a X-ray diffractometer. So, here you can see that on in here it is written power, then X-ray, shutter, okay, on off. So, from outside itself you can see whether X-ray is on or not, whether it's a X-ray is produced. So, some shutter is there, we just can close the exit of the X-ray using the shutter. So, now we this the when you will work in this machine. So, one has to be very careful, because X-ray, if it is exposed to human body for a long time, then there will be damage. So, it is a radiation. So, one has to be careful when we are going to use the spectrometer. So, it is a door, I will open it, this door. If I open this door, and I will open this back side also to show you, just I can open it. So, here you can see, when I open door, immediately I am able to see here, this is the basically here we put sample, this is the sample holder. So, this just glass slide we use for putting our sample. Okay. So, say we have aluminum powder, here you can see we have aluminum powder. So, this aluminum powder, if I want to do experiment on this aluminum powder, or sometimes we give to student that aluminum powder and copper powder to test, to find out the composition ratio of copper and aluminum in the sample. So, this you can see powder, this is the sample powder, we put slight amount of powder on this, okay. So, just paste it, spread over it, okay. So, this sample, that sample, now I will put in sample holder, here I am putting, okay. So, now sample is there. Now, here you can see, here there is a X-ray generator, here I will show you from back side. So, from this X-ray generator, this X-ray will come, and there is a filter also inside. So, monochromatic X-ray or X-ray, this is the copper, target. So, copper K alpha, this wavelength is 1.54 angstrom. So, that K alpha X-ray will come and fall on the sample. Okay. So, now, so as I told this, we do not need to vary the angle of the sample, okay. So, this basically this is fixed, and with this you can see this one handle kind of things, and on that handle there is a detector here. So, this is a detector. So, it is a X-ray detector. So, it basically can measure the intensity of the X-ray. So, as I so for any detector, basically in this case X-ray will fall, and that it will produce equivalent number of carriers, and due to that carriers will get current or voltage. So, that current or voltage is proportional to the intensity of X-ray. So, that way this detector tell us the intensity of X-ray. Okay. So, now the detector, it is on this lever. So, now that detector have option here, we use stepper motor. So, it will vary with some step. Okay. So, you can specify that step 0.1 degree or 0.2 degree or 0.5 degree or 1 degree step. So, it will from 0 to it will in different steps it will change, the angle will change, 2 theta is changed basically. So, it is this angle is with respect to the incident X-ray. Okay. So, now theta, the detector are moving. So, that angle we are telling with respect to the incident angle of the X-ray, this that was up to 90 degree and we scan. Okay. So, then you will get this type of, as I mentioned, then basically it is interfaced with the computer. So, this is so this computer screen you will see this type of pattern, diffraction pattern you will see. Now, using this diffraction pattern one has to analyze and find out the find out the different parameters of our interest. So, that I will discuss how to analyze the X-ray and get the information. So, let me so from front side you cannot see all in better way. So, I will try to show the all components from back side. So, I have opened the box. So, from back side you can see that so as I showed you that this is the sample holder. So, this sample here I have put sample. So, this powder sample, so on a glass plate. So, we put in the sample holder. Now, this is fixed, but the detector, this is the detector, X-ray detector which can detect the intensity of X-rays. So, this is on this lever, on this arm. Okay. So, this arm you can see this free to move from 0 degree to 90 degree. So, we use stepper motor. So, backside you can see that there is a stepper motor. So, this stepper motor is basically rotate this detector with respect to this axis passing through the center of the sample. So, this rotational axis is basically axis of the sample holder. So, now this is the X-ray source, this is the X-ray source. So, from this X-ray source there is a filter inside, you cannot see. So, now this X-ray filtered X-ray K alpha, this is the copper target. So, that will come and fall on this, and this detector will start to start this rotation of the detector with some particular step. So, from computer everything is controlled. So, now this detector will rotate at different steps. So, this we are telling the change of 2 theta. So, at different 2 theta it will collect the X-ray intensity. Okay. And then that pattern will appear in the, this pattern will appear in the on the screen of computer. So, this I have taken the aluminum sample powder. So, sometimes any other sample in powder form we have to take. So, these are basically geometry suitable for powder method only. So, in some better diffractometer where this rotation of this sample as well as rotation of the detector, both facilities available. So, in that case we can study the thin film or bulk material, but in this diffractometer only, even if you want to study thin film or bulk material, if you want to know the crystallinity of the material, so you have to bake this bulk material or thin film and make it powder, and that powder you have to use on this on the sample holder and do the experiment. So, this, as I told, this X-ray machine have one part is X-ray generation. For that we need chilled water, cooling water. So, here you can see this some pipe some pipe has come from outside. So, this the chiller is outside. So, from outside this water pipe, chilled water will come, and this is connected with this instrument, this is connected with this instrument. So, that chilled water is coming to the instrument. So, the chiller is outside. So, again so that chilling part is here inside around the X-ray tube. So, it is a very small machine, it is the low power machine, it is for teaching laboratory. So, we can it's I think it's its kilowatt is around 6 kilowatt. This power is 6 kilowatt. No, 18 kilowatt is one third of that one. So, 6 kilowatt. So, accordingly voltage and current that specification is there. So, inside, if you see inside, there is a not you see this looks very simple, only this X-ray generator. So, this is the standard generator. Okay. Now, we need sample holder. Now, with respect to this sample holder, there will be detector. That detector should rotate with respect to the axis passing through the sample holder. So, for rotating the detector, so we use stepper motor. So, that stepper motor, some gears are there, here some gears are there, one can see. So, that that stepper motor that is also standard. So, that stepper motor is connected with this detector holder, and from computer programming one can choose the step of this change of the angle 2 theta or change of the angle of the detector, and from 0 to 90 degree we scan, and on screen we will get the X-ray diffraction pattern. So, now that X-ray diffraction pattern we have to analyze for getting the information. As I told that if aluminum powder and copper powder this mixture, if I give you, then what is the ratio of these two phase, two phase, one is aluminum and another is copper, what is their ratio in this mixture. So, that one can find out. That is generally this experiment we give to our student. Also one can find out what is the crystal structure of aluminum, what is the crystal structure of copper, and many more things one can analyze from the X-ray pattern. So, that is more important than doing this experiment. Generally, if you give samples, so our operator will give you the data, the X-ray pattern, the data they will give you. Now, it is our task to analyze this data and find out different parameters. So, that I will discuss, if possible I will discuss later on. So, I will stop here. Thank you.